Thank you. Hello, everyone. So we have heard a lot of things about Apache Kafka, Flink, Iceberg. I'm going to move away from the architectural side and towards the observability side of things. So we have all of these amazing things, but how do we make sure they're running smoothly? That's what I'll be talking about today. So, and with OpenTelemetry. Before we get into it, this is just a safe harbor that this presentation and whatever I say here is just for informational purposes. And please do not construe it as an offer from New Relic or anything like hold me responsible personally. Don't go back to my boss, please. Okay, so I'm Mehreen Tahir. I'm working as a software engineer with New Relic for past 3.5 years. And today we are going to focus on observability through OpenTelemetry. Show of hands quickly who have worked with OpenTelemetry or who just know about OpenTelemetry. Oh, quite a few people. Anybody would like to share some thoughts around it? What is it? What you do with it? How you like it? Few words? No?
This is the distinction between monitoring and observability. I mean, OpenTelemetry comes with given standards like a collector. The collector APIs are across the board very useful and makes a distinction between monitoring systems and observability.
Yeah, that's a very good answer. Okay, so follow-up question, anyone? Since you know the difference between the monitoring and observability, has anyone ever used any other observability tools? Anybody familiar with New Relic, Datadog, Prometheus, anything?
We are using Elasticsearch.
How do you like it?
That is predominant for us,
So you're just going with the flow? Okay. So, but I'm not sure if anybody went through that transition where you have to change the vendor. So, for example, your company just doesn't want to use Elasticsearch anymore. They want to use some open sourcing tool or something. You have to go in, change a lot of lines of code where the monitoring is happening, and then make sure it works with the new platform, which is a real bummer, and that just adds a lot of work on developers' plate. So to counter that, we have OpenTelemetry, which was introduced in 2019 from the merger of Open Tracing and Open Census. And the idea was to standardize how observability happens. So instead of locking you into a vendor like Elasticsearch, New Relic, whatever, they focused on vendor agnostic part of the observability. So instead, they give you a set of APIs, libraries, integrations, and a collector service to collect all the data from your different services and send it to any vendor of your choice. So you still have the observability, but you don't have to go back into the code and just redo everything for the sake of observability. Like I mentioned, it is open standard, and that's one of the main selling points for it. It's cloud native, vendor neutral. You only need to instrument once, and whenever you change your vendor, for instance, all you need to do is just change where the data goes. You don't need to change what data you're collecting. So that's a good thing, and it's interoperable. So it doesn't matter whether you're a software engineer, you're in DevOps. It has something for almost everyone. So let's take a look how OpenTelemetry does all of this. And like we mentioned, it receives the data, it collects the data, and then sends it to some vendor, some platform of your choice, right? So in between that, there is a processor which just decorates that data in a way that you want. So first step, we have language and framework specific SDKs, which are responsible for collecting data. So they are like the translator, for example. If you're, for example, observing microservice architecture, and one of your services in Python and the other one is in Node, but you want to make sure you're collecting data from both of them, and for that, you need two language specific SDKs, but you need the same type of data. for instance. So you need to make sure that there's a service that translates them in a format which is understandable by the observability platform. On the next step, we have processor, where basically you define how you want to collect this data. Whether you want to process it in batches, or you want to add some attributes to it. All of that happens at the processor stage. And last but not least, the exporter, where you send your collected data to a backend service, which could be New Relic. Just to make it clear, I will be giving examples of New Relic because I need to get paid. So let's have a look on what this would look like for Apache Kafka. This is an OpenTelemetry demo application, simple e-commerce platform, which is using microservices architecture. So you have front-end, back-end services, checkout, cart service. But the main focus for this is this portion, where we have Kafka in here. So what's happening here is checkout service is connected to accounting and fraud detection services through Kafka, which is going to be the messenger. So we'll see how we can monitor, especially this part of the service. We saw 3 stages before, and before I get into it, as a disclaimer, OpenTelemetry gives you 2 ways to instrument your application. One is auto instrumentation, where you just need to export a variable and you're good to go. It will monitor all the built-in features automatically and send it to the backend. The other one is manual instrumentation, which we are looking here. So for this one, where we are monitoring that side of Kafka, what's happening here is we are going to define, first of all, the receivers, what we want to collect. So on the screen, you'll see we have defined receivers for traces, matrix, and logs. And those receivers are OTLP, which is OpenTelemetry standard protocol. You have also defined processor, like how you want to collect this data. For example, we are adding a few attributes because it's a Kubernetes cluster, so we want to add a value and what's happening, like an action to it as well. This will just help us later on when we are queuing this data. And last but not least, where it will be sent, which is New Relic. And whichever platform you're using, you need to specify any headers for it. For example, here, we need to specify New Relic license key for the data to be exported. Once you have all of this, then you can just deploy your application using the Helm chart, and all the data will be, all the observability data will start collecting, and it will automatically send it to New Relic. So once your data is in New Relic, this is sort of a high-level overview of what the trace would look like. So we're covering each part of the application, from front end to checkout service to all the other services that it is connected to. Again, what we were focusing on was fraud service. So how the trace goes from front end to checkout to fraud detection service. This is the overview of that trace in New Relic. So this is here, order processes, and it takes you down to fraud detection services. And you can then drill down into each piece of the trace, how long it took, where it took longer. Maybe this helps you on a granular level just to detect where things may be going slow or going wrong. And then you get all the Kafka consumer and producers related matrix in New Relic as well. So this one just shows a few consumer related matrix. Okay, so we just saw tracing. We did not see any matrix or anything else. So let's talk about matrix for Kafka Broker. This is where the fun part comes in. Auto instrumentation. I know that code looked a little bit scary. So many things to remember. Auto instrumentation is so fun because all you need to do is define one environment variable. Like literally just execute this command on your screen and you're good to go. So what we're doing here is we are taking the OpenTelemetry Java agent and specifying the target to be Kafka Broker. That's it. You can follow the link to see it in more details, but that's all you need to do. And this is what it gives you: a long list of metrics, and people who have been working with Kafka Broker would know much better than me on how important these metrics are. And this is collected as a time series data. So over time, you'll see when if there are any sudden spikes, if the things went wrong, downtime, all of those things. So you have access to a broad range of metrics. But what if you're running a managed Kafka like clouds, Confluent Cloud? OpenTelemetry has something for you there as well. So you can use simply Prometheus OpenTelemetry collective and monitor the Confluent Cloud as well. Again, this is an example using New Relic. All you need is a New Relic account, a license key, Confluent Cloud account, and API key and secret to go in and see what's happening. Again, you're using OpenTelemetry protocol or TLP, which is standard here. Okay, and again, back to the scary part where we need to specify a few things, but just 3 things you need to remember. What was the first one? To collect the data. Receivers, right? So first, we need to define what are going to be the receivers here. Then we need to define, we're going the other way, yeah. And then we need to define where will we export this data. So we are going to define the target for the receiver, which is Confluent Cloud, a bunch of other things that we need to specify. Then we move to processor. This is where we are defining what will happen to our data before it is sent to the backend. So here we're just saying, batch my data. I don't want to keep streaming it, batch it, and then send it. That's really important for when you don't need real-time data. You can manage a few seconds delay. And then you just need to specify where it will be exported. Again, New Relic, API key, and that's all you need. And that gives you access to all of these metrics. You have service active connection count, sent record, sent bytes, partition count, retained bytes, received record, all of these, which will help you optimize the performance of your Confluent Cloud. Again, this is just a better looking fancy dashboard that we created for you guys. So you'll, again, kind of similar things that you are seeing here. You see the topics, partitions, consumer groups, connectors, but just in a more refined format. You see the time series data. So when taking a look, I can see maybe something went wrong here, right? So just makes it easy for a bird eye view. Okay, so now let's move to Apache Flink, because we said we're going to monitor and observe all the things related to Apache. So Apache Flink. We have OpenTelemetry Flink matrix receiver, which makes it easy to monitor Apache Flink. It's in alpha state, which means it's not like as mature as some of the other offerings from OpenTelemetry. But it's pretty decent because it will use Flink's REST API to collect job manager, task manager, and all the other operator related metrics. So again, you can follow the documentation. It's easy to follow. If you have any questions, please feel free to reach out. Again, we are defining what data we want to collect, how we want to collect it, where we want to send it. So here, there's an interesting thing as well. So we are collecting the Flink matrix, but you'll see that we want to collect them every 10 seconds. So this is just another way to customize how you want to collect the data. Then we want to process it in batches. We're adding a few attributes, which will make it easier eventually for us to query the data. And then we are defining the exporter. One thing that I might not have mentioned earlier is you'll see that we are defining what kind of data here as well. Like under the service, we're defining if you want to collect the metrics, logs, traces, that's where it goes. And then it just basically tells it everything else. Like if we want to collect the matrix, what receiver, processor, or exporter we are using. just creates different pipelines. So matrix will be collected through a different pipeline, and then traces will be collected through a different pipeline. And it's perfectly easy and normal for you to just want to collect one thing. Okay, so here is again a long list of matrix that you get in New Relic when you're using OpenTelemetry. So you'll have checkpoint count, checkpoint in progress, checkpoint size, restart count, CPU load, CPU time, and all the other bunch of stuff. Again, we don't want to scare you, so we made a fancy looking dashboard. And kind of similar what you get like in the previous one, but there you need to go into individual matrix and see what's happening. Here you get a bird eye view of the overall health of your Flink. So we have been talking a lot about Iceberg, and it's pretty scary to be here right now because unfortunately OpenTelemetry does not support Iceberg out of the box. Any reason why? Wild guesses? It's not emitting any telemetry data basically. Like once the data is in the Iceberg, there's not much to do with it, right? So that's the bad news. But the good news is almost all of us are developers here, and our job is to find workarounds, right? That's what you get paid for. So what we can do is we can monitor the system around the Iceberg. For example, if you're taking the data from Apache and moving it through Flink, why not monitor the Flink jobs? Right? That will give us good enough information. If the data is taking too long, we can see if it's a big chunk of data, it is going to take long, but sometimes you just want to move it quickly, like you were saying. So maybe that will help optimize it. So I worked on a simple example for tracing Iceberg write jobs in Flink. So the easiest way I could think of was to start a span at the job submission. So right when we are picking the data from Apache, that's when we start the span. And then we add the child spans to it when the catalog is being loaded, when the table schema is being checked, data write operation, commit time, and that will give us quite helpful information, right? And we're going back to simple OTL configuration. Here I'm just defining that I want the traces and matrix. Exporter will be New Relic and receiver is going to be OTLP, which is like the baseline. So since I'm very new to Iceberg, ignore the unknown service tag at the top. I did not define a name, I completely forgot. But you get distributed tracing with just those few lines of code. Here, we have a trace group Iceberg Flink job. When we go in there and we drill down into process spans, we see that we can see catalog initialization, table check, table insert, and how long each of these operations took. It was a very small data set, so it's going to be milliseconds, but this is just to show you the level of detail you can get through OpenTelemetry. Then again, you can add a bunch of attributes to it. You can add multiple level of detail, like whatever you want to specify in here. I had added a few attributes, which I'm not showing here, but you get the idea, right? And yeah, there are a few other ways as well with OpenTelemetry. So this is through Flink job. If you want to go a little bit deeper, maybe you want to use the REST API on the top layer of the Iceberg, and that can help you with monitoring. Or we can also monitor other jobs related to it. Okay, so to summarize, open source is here to stay. OpenTelemetry is here to stay. And the power of open standard is that it gives you a lot of options to capture the data, export it, and you can customize it at each and every level. Maybe you want to capture the data, you want to send your logs to New Relic, but you want to send your matrix to Prometheus, right? Your choice. So you get a lot of customization option, and you can specify the level of detail you want. It it also has a broad industry support. New Relic is a very big supporter of open source and especially OpenTelemetry. All of these mostly are owned, like all the code contributions are basically owned by individuals. So many community contributors, and it's here to grow. And with that, thank you. Any questions?
Interesting. In your receiver, you seem to be able to encode the syntax of the data, but not the semantics of it. Can you capture the semantics as well? So, because you can have different sources which mean the same thing, but they have different labels, and you can have different. Either you build a unified receiver, or you receive whatever they send you and define the semantics, so you normalize afterwards. Is there a way of doing semantics as well?
I'm not sure I still understand your
So
question.
let's say I have two systems where I call a counterparty X, and the other system calls it Y.
Yeah.
I build a receiver, so I can say counterparty receive X, the different system receive Y.
Yeah.
Or I can say receive X and receive Y, but the meaning of these things is counterparty.
Oh yeah, you can define the attributes. So if it's the same name and you want to differentiate between the two, you'll have to define the attributes. Otherwise, it wouldn't know.
It just trying to receive data, but it doesn't tell you what the thing means. It just says I'm a receiver, receive some number. What does that number mean? Semantics are not there.
Okay, I'm still lost.
Systems are looking what you're calling the same
Yeah.
fundamental the world exists, the world exists, but I can call it different things because that language is different. For example, I'm trying to think, Apple, collective language calling Apple two different names.
Yeah.
Apple is an apple. So when you're receiving data, you can say an Italian apple or an English apple.
Yeah.
But I can store data in Italian and in English. But somehow I need to know that I've got an apple somewhere. Data contracts, same thing.
Yeah.
Can we code data contracts with you?
Yeah, you can. Yeah. Sorry, I only now I understood.
That's what I would do.
And if you're capturing like even the same data through different language specific SDKs, so like I mentioned, like Node has different way of capturing the data automatically, and Python gives you the same data but in different contexts, so you know where the data is coming from.
Any other questions? No? Okay, yeah, we'll also be on YouTube in the next couple of weeks, so yeah, look out for that. Thank you everyone that's come tonight. See you soon.